Hi, and welcome back to my OpenTK 2D game engine / framework series. This is part 6, and in this episode we are going to abstract buffers into reusable classes. Because this, right here, keeping track of these ints and declaring them in our low content method, this is just really not sustainable. So if you remember from my last episode, we got textures to load on the screen, and we immediately abstracted that away. And I think that this is also a good stopping point in terms of having a file we can go back and reference. If you remember from the last episode, I showed how you can very quickly just kind of create a copy of this. I'll do it again, just follow these steps closely. So just go ahead and open up your texture test, what we had in the last episode. Hit Control A or select all, hit Control C, then go into implementations and add a new class, and we will call this one Buffer Abstraction. Highlight everything in this file, hit delete, and then Control V or paste. Then change this, the class name and the constructor, to Buffer Abstraction. And then go into program.cs and change this to Buffer Abstraction. Let's go ahead and run this and make sure it looks the same. And it does, perfect. So before we get started on Buffer Abstraction, there is one small change that I would like us to make in our implementation. Currently, getting access to the game window would require jumping through some hoops. So we're going to streamline this by making a display manager class, which will be a singleton, so we're guaranteed to only have one instance of it. And it will handle creating the window and managing that reference. So we can reference the display manager to get the current window. And then also, right now, if you notice, when you launch this, it's not in the center of the screen. While we're doing that, we will also set it up to start in the center of the screen. So first, let's start by adding a display manager class. So go into GameEngine.tk.core and management, and add a new class and call it display manager. And it can stay in the management namespace. Let's make it a public sealed class. And then we will have a private static instance of itself. So static display manager underscore instance equals null. And I know it's gonna probably bark at us here and say, hey, you should declare this as nullable. It's not going to be null. So I wouldn't worry about that. If you want to declare it as nullable, go right ahead, but then you're going to always have to check for it to be null, and the display manager is going to take care of instantiating itself. So if you're trying to do something and it blows up, you probably didn't do it right anyway, because you have to use instance. So anyway, we also need to make a private static read-only object. We call it lock. And we're going to keep a reference to the current game window. And we need to bring in window, because this is just the base class, so just call it game window. And we'll make its instance here, so static display manager instance. We'll have a getter on this. Let's lock the lock. Check if instance, oops, wrong one, if instance is null. We'll set instance equal to new display manager, and we will return instance. Okay. And then the next thing we need to do, this next part that we're going to do is they're going to use some unsafe code. So go into GameEngine.tk.core. You can double click it and then add it in here. I believe you can say allow unsafe code in here. If you know how to do that, go ahead and do that. But if you're not familiar with that, right click on here, go to properties, and then go to build, and allow unsafe code. Go ahead and click Save All. And then now we can use the unsafe keyword. So we'll have a public unsafe game window. We're going to call it create window. We're going to pass in the game window settings. Game window settings. Native window settings. And that should be good. We're going to instantiate game window here. A new game window. We'll pass in the game window settings and the native window settings. And we're going to keep track of the x and y here. So do int x, int y. And then we need to get the monitor info. So we can do that by using monitor info. We'll call it current monitor equals monitors dot get monitor from window. And if you look at that, you can see that it accepts a pointer, and that's what we're going to be using, is the pointer to the window. Well, and that's why we needed this unsafe code, otherwise we wouldn't be able to make use of that. We could, I think we can dereference it, window, and pass it in like that. Maybe not, but that's fine. We don't need to go that far, because we can simply just do game window, and then just grab the window pointer to it. And then it will take that as valid way to pass in the pointer. Then we need to create a rectangle and import system.drawing. We'll call it monitor rectangle. There's new rectangle. And we're going to use 0, 0 because the rectangle is going to start at 0, 0. And then its width will be the current monitor dot client area dot size dot x, and then current monitor dot client area dot size dot y. And then now what we need to do is use the rectangle object to determine where the center is going to be. And that's pretty easy to do, because we can just go x equals, and we'll do monitor rectangle dot right plus monitor rectangle dot left minus the native window settings dot size dot x, and then we want half of that, so divided by 2. Y, we do something similar, except we're working from the bottom and the top. So we're going to do monitor rectangle dot bottom plus monitor rectangle dot top minus native window settings dot size dot y, and then half of that. And then that should put us in the center. Now we do want to check if x here is less, if x is less than the monitor rectangle dot left, then we just want to put it to the left. So we'll just put it at monitor rectangle dot left. Shouldn't happen, but you just never know, depending on the monitor. Otherwise, it's going to put it out of bounds. We'll do the same for the y. If y is less than monitor rectangle dot top, then we'll set y equal to monitor rectangle dot top. And then we need to tell it the client rectangle. So we do game window dot client rectangle equals new box I, and we're going to, I want to bring in the full thing. Hold on, box 2I. And we're going to use the OpenTK mathematics library here. And we just simply pass in x, y. So where is it going to be on the monitor for x, for the x and y position? And then what's the size of it? And that would just simply be the x location plus the native window setting size x. So x plus native window settings dot size dot x. And then for our y, it's the same thing. It would be our y position plus the native window size dot y. So y plus native window settings dot size dot y, and then we will return the game window. Okay, so let's get rid of our using statements, make sure we're keeping things clean. So far this looks good. So now we'll go into our game class, And we're going to implement that. There was one thing that we probably should call out for the sake of being thorough. We'll add 3 more settings, or 1 more setting to the native Windows settings to just make sure the context API knows that it's OpenGL. It's assumed pretty much, and that's the default, but we might as well make sure we're doing this properly. So it'd be native Windows settings.api equals context API.OpenGL. And then we want to add 2 more properties to our game Windows settings, and we want to make sure the render frequency is set to 60 FPS. And we want our game Windows settings.update frequency equal to 60 frames per second. And then down here, instead of calling new, we will just call our display manager. So we'll do display manager. I bring in OpenTK.core.management.instance.createWindow. And we'll pass in the game Windows settings and the native Windows settings. And I think all this just stays the same. I don't think we have to do anything else. All right, let's... It says I have an error. Oh, semicolon. All right, I'm going to build that, make sure we don't have any build errors, and let's see if it opens it up in the center. And it does. It's right there in the middle. Perfect. So now let's get into the meat and potatoes of this episode. I just want to call out something that I just noticed here. So I don't mean to get all personal about my life here, but I take Ambien, and sometimes I do weird things when I'm on that at night. I apparently added this to GitHub on my sleeping pill, so this is a pleasant surprise. Anyway, let's create a new folder inside OpenTK core here, and let's put... I think actually it belongs in rendering. I think that makes the most sense. So inside your rendering folder, create a new folder and call this buffers. Okay. So all buffers are going to kind of share the same thing. Like let's take a look at our buffer abstraction here. They all have a ID, right? They have some kind of integer that represents their ID. They all have a bind method and an unbind. Well, maybe not vertex arrays, but vertex buffer objects and element buffer objects, or index buffer, and I want to call that out. I'm calling it element buffer object because that's what a lot of tutorials call it, but to me, I think of it more as an index buffer, and it's referred to as an index buffer. So going forward, we're going to create this class, and we're going to call it an index buffer, and we're going to start calling it that from here going on forward. So let's create a interface that all these are going to have to conform to. Let's call it iBuffer. And in this, let's remove this. It's in the GameEngine.tk.core.rendering namespace, and we can make this public. And it's a class that is interface iBuffer. And in this, we're going to make sure it has, we'll just call it buffer ID. So it's going to be int buffer. And then this should only have a getter. It's not something you should be able to set outside of it. It just should be set when you create it. And all of them need to have a void bind method and a void unbind method. Not unbind method. And let's remove our using statements. So let's start with the index buffer, because that one I think is probably the easiest one. So let's take a look at what it would take to replace that. We're going to leave our vertices and indices in here, because this is not going to be part of our abstraction here. That will come at a later time. But first thing we have for the index buffer is we have an integer that keeps track of it. And then we call genBuffer on it, and we also bind that buffer and then set the buffer data. So from that, that should be pretty straightforward in terms of what we need. So we obviously need the buffer ID, and we need to know what the indices are. So inside our buffers folder here, go ahead and add a new class and call it index buffer. Index buffer. And remove this buffers namespace and just leave it so it's in GameEngine.tk.rendering, and it's going to inherit from iBuffer. Let's go ahead and implement that interface. We just need a getter on it. And then bind. Actually, let's create a constructor here. So we'll do public index buffer. We're going to pass in a uint array of indices. There we go. And then we're going to set that buffer ID by calling gl.gen. GL, I'm going to bring in that namespace here. Remember to use OpenGL4. gl.gen buffer. And we could really just kind of copy the code here from our buffer abstraction here. So let's do that. We already wrote out this part here, but this is really all we need to do after that inside the constructor. So inside our index buffer, and we'll just replace this with the buffer, this with indices, and I think that's all we need to do for the constructor. So then now all we need is just a bind and unbind method, and we can take the bind, we'll just do gl.bind buffer, do buffer target, element buffer, array buffer, and then the buffer ID. And then an unbind, you know, we really could make an abstract class that does the unbind part, but that's okay. We don't need to get too carried away. We just simply bind it to 0. That just tells it that the current bound buffer is null. That's just how you tell OpenGL that. So let's go into buffer abstraction class here. And instead of having our buffers handled here, we're going to just call it directly. So we'll keep the vertex buffer object, but we're going to comment this out, and we're going to say private index buffer. Now we have to bring in the namespace. Come on, Visual Studio. Okay, I'll just bring it in manually. It doesn't want to help me. Go up here, we'll do using OpenTK.rendering. Why doesn't it like this? I'm going to pause this and come back. That's bizarre. Ah, yes, it needs to be public. Okay, now we should be good. And then what we'll want to do is we need to gen the buffer, bind the data, and that's all handled in the constructor. Of course, we're going to call this index buffer. And in here, we will simply do index buffer equals new index buffer, and we'll pass in indices. Indices does not exist in the underscore indices. Okay. And we'll go ahead and just comment this out because we no longer need it. Okay. And then down here, none of this changes. So I think that's all we need to do to get the index buffer to work. So let's try that out. So if we see the wall, then we're set. We do not see the wall. What do we do wrong here? Got the index buffer, we're calling index buffer. Oh, I'm probably not binding this at any point, am I? That's right. Ah, I need to bind it down here before it can actually draw. Yes, that makes sense. So underscore index buffer dot use or bind. And now let's try that. And we're still not getting anything. What else are we missing? Index buffer, GL bind vertex array, GL draw, triangles, indices, length. I'm going to pause this and I'll be right back. Okay, to clarify, I never claimed to be smart. So, obviously, I was replacing vertex buffer here. That was incorrect. Go ahead and uncomment out vertex buffer object, and then uncomment this code here. And we'll leave that all in place. Take our declaration of index buffer, remove it from here, and then let's go down here and then call new index buffer to replace the actual index buffer stuff, because that would make sense, right? All right, so now element buffer object, our old one, no longer is being referenced, and I should have probably put this down here so it makes more sense. Just move that there because we're replacing it. And then index buffer, we are just calling bind, and then draw elements, and then the indices. And there we go. Now we are able to see our texture. Everything is working as it was before. So that's great. We can go ahead and remove this element buffer object. We don't need it anymore. But now we need to work with vertex buffers. And those are have a little bit more complexity and nuance to them. But there's a pretty straightforward way to still do this. So inside your buffers object, we need to create a vertex buffer. Call it Vertex Buffer and make it public. Call it interface, or no, not interface, and we'll inherit from iBuffer. Let's clean up the namespace here so it remains in rendering, and let's go ahead and implement the interface. Change this to a get. Oops, how's that? And then, pretty similar to how we did the index buffer, that's all this class is going to matter. It's kind of actually when we get to the vertex array when things get a little more complicated. So our vertex buffer, if we remember here, it needs to take a list of vertices here. So let's make sure that's part of its constructor. So we'll go ahead and generate a constructor for this. And then we will not be passing that in. And it will take a float array, and we'll call it vertices. Okay. And the buffer ID will be equal to gl.gen gl, bring in the namespace for OpenGL4, .gen buffer, and then we'll do gl.bind buffer, buffer target, buffer target dot array buffer, and we'll use the buffer ID. And that should be good. And then we need to provide it the buffer data. I don't know why I copied that line. I meant to go back to here. We might as well be doing some copy paste here to save time. Buffer abstraction. So our vertex buffer, we'll just go ahead and steal this line here. And then this will become vertices. All of this stays the same, nothing changes. Let's move this up here, keep it clean. And then we need our bind method, which we will just go ahead and type that out by hand. So it's gl.bind buffer buffer target dot array buffer, buffer ID, and then for unbind we just simply set it to 0. Let's remove all these extra using statements up here that we don't need. And then in our buffer abstraction class, now we're going to work on getting rid of the vertex buffer object. So let's start by commenting this out so we know what breaks. And we will we'll make a private vertex buffer. We'll call it vertex buffer. And then instead of calling this here, we're just going to make a new instance of it. So we'll say vertex buffer equals new vertex buffer, and we'll pass in the vertices. We can comment all of this out. And then down here, we don't need to do anything for the vertex. Yep, so when we have our vertex array, which is still needs to be abstracted away. So our vertex buffer, that's all been abstracted. I don't think we need to call bind on this one immediately anyway. Let's go ahead and launch this, and that looks good. So everything looks the same. So now we need to start working on abstracting away the vertex array. And that's where things get a little trickier, because this is where we're kind of defining what that data looks like. So just to recap how vertex array objects work is you gen a vertex array. The others are gen buffer, but go ahead and remove this. But the vertex array has its own generation method. You're binding it. And then we have to set the vertex attrib pointer, because remember we're saying at index 0 read 3 floats, and we don't need it to normalize it for us, and then its stride is 5, because there are 1, 2, 3, 4, 5 times the size of float, and it starts at 0. There is no offset. And then we have to enable it, which is part of our shader location 0, so it knows that's where this position is at. Then we access the vertex attrib pointer of index 1, which in our texture is a text chord, and we need to tell it that there's 2 of them that are 2 floats, does not need to be normalized, we already normalized it, and the stride is still 5 times the size of float. That's still how large this data is, but start at offset 3. So it starts at 1, 2, 3, and then reads these 2 floats. So what we need to do is we need to have a vertex array class, and in there it will have bind and unbind. It'll have a buffer ID, and then we need the ability to add vertex buffers to it. And then not only just add vertex buffers, we need to also be able to supply it, hey, what does the layout look like? So it knows that it needs to enable these attribute pointers. So let's go ahead and start by creating a new vertex array class. We'll call it vertex array. And then from here, well, we gotta make this public, of course. And we'll remove from the buffers namespace, and we make it inherit from iBuffer. I'll implement that interface, change this to a get. And let's go ahead and create a constructor. This constructor will actually take nothing. Let's move this up here. Okay. And then inside here, we're going to do the same thing. We're going to gen the vertex array. So let's take a look at our buffer abstraction here, and we'll call this same method. Except we'll say buffer ID equals gl.vertex gen vertex array. Bring in your OpenGL4. And let's add a deconstructor to this, because this does use up resources, so let's let it handle this automatically. We might end up making these inherit from iDisposable in the future. It really doesn't matter, however we want to do it. But we will call delete vertex array, and then we'll set the buffer ID to be the buffer ID. And in our bind, we'll just simply call gl.bind vertex array, then the buffer ID. And then in our unbind method, we just simply set it to 0. Okay. And then now we need a way to specify what it's the vertex buffer data. So we'll need a constructor here, or not a constructor, but a method called public void add buffer, and we'll pass in a vertex buffer, and we'll just call it VB. I don't like doing that. Vertex buffer. OCD is getting to me. Okay. Now, when we add a buffer, we're just going to call bind, because it needs to know what's the active buffer at this point in time. So we'll call bind, and then we'll call the vertex buffer the vertex buffer .bind method, so it does get bound, and we need a model that's going to track the layout. So let's add a new class, and we'll just simply call it buffer layout, because that's what it is. Buffer layout. And inside our buffer layout class, let's also keep a struct, but we don't I don't want to create a whole new... I don't know. I suppose we could. Yeah, let's do it. Let's create another class, but this one's actually going to be a struct. And let's call it buffer element. We'll remove that from the namespace. We'll make it a public struct. And in here, it's going to have a reference to the vertex attrib pointer type. So we can define what type of data it is. So it's a public vertex attrib. Wow, I cannot type today. Vertex attrib pointer type. And then we'll bring in the namespace for that, OpenGL4, and we'll call it type. We'll make a public int count, and a public bool normalized. Just so, because that's the type of data we need, because we need to know what type it is, what's the count, and is it normalized. Let's take a look at our buffer abstraction, the type, the count, and if it's normalized, which is always, we're always supply it being normalized because we take care of that. So let's go ahead and remove these unnecessary using statements. Let's go back into our Vertex, not our Vertex Array, our buffer layout class, and let's go ahead and create a constructor for this. I don't think we need to pass anything in. No, but we do need to lay it out, because we need to keep track of the stride too, and our elements. So let's make a private list buffer element. We'll call it elements. Set it to new for now, so we don't have to remember to new it up and have it blow up on us. And we'll make it private int stride. And then we want to set the stride to 0 when we instantiate it. And since we're keeping this private, we want to maintain it within here because we just don't want to be able to just add it outside of this class. I think there should be some rules in place on how you can add them. So let's make a method that's just going to return the elements. So we'll just say public list buffer element. I'll call it get buffer elements. I think we can just do this, right? Yep, so that should return it. And same thing for stride. We'll make a public int get stride. And we'll just return stride. And we need to accept some generics here. I cannot think of a extremely clean way to do this. I know that there's in C#, the newest version that's in pre-release. There is a way using an interface called iNumerics, and it lets you specify what types of data you can pass into it. But we're not going to use that because it may not make the cut in the new version of C#. So let's create a public void add. It'll be of type T, and we need to pass in how many there is. So int count bool normalized, and more often than not it's going to be, so we'll just make that an optional parameter you can pass in, but by default it's false. And to enforce that when you're adding this, that it's a number, this doesn't guarantee, but we'll have a throw an element if you don't pass in a proper number. But the best way I found to do it is say where T is type of struct. So that means obviously you could pass in a struct like a buffer element and that would not be valid, but you can't pass in, say, like a string or anything like that. It's still going to restrict it to being a number or a struct, which we obviously don't want a struct. But anyway, let's go ahead and write a method that's going to set the stride and set the type for our element. So it's going to be kind of like it's just adding it to these elements. So let's do vertex attrib pointer. Spelled something wrong. Vertex attrib. Oh, pointer type. Pointer type. Bring it OpenGL4. And we'll just call it type. So if type of float is equal to type of T, So this is checking if it's a float. We're going to set the type equal to the vertex attrib pointer type dot float, and then we'll set the stride be plus equals size of float times the count. So this way we're keeping track of that stride, and we're incrementing that stride based on the size of the float, based on the number of elements, so we know what the stride is. We'll do else if we're going to support 3 types, just call it out. We're going to support floats, unsigned integers, and unsigned bytes. You can probably support more if you want, but those are the only 3 we're going to support. Chances are we're just going to use floats, but I want to make sure we have some flexibility later on if we choose to pass in more. But since this is just a 2D game, we don't need to go too crazy on this. So I'll get 2D game engine, sorry. So we'll do type of uint equals type of t. Then the type becomes vertex attrib pointer type dot unsigned byte, and then we have to increase the stride plus equal to the size of uint times the count. We'll do else if type of byte is equal to type of t. So this would be just us passing in a byte, and we're going to set into type equal to vertex attrib pointer type dot unsigned byte, and then we'll increase the stride by the size of byte and the count. Byte times count, and then stride plus equals else. In this instance, that means we were not passed some good data, so we're just going to throw a new argument exception. Oh, not throw async. Throw new argument exception, and we'll pass in a message, and we'll say type of t is not a valid. We'll know what that means. And then if this all worked, then we'll just go ahead and add that element to the list. Elements.add new buffer element. The type is equal to type, count is equal to count, and normalized is equal to normalized. Okay, I think that covers it for our vertex layout. Oh, yep, gonna remove our using statements. Okay, I think that looks good. So let's go back to our vertex array, and inside our add buffer, let's add the buffer layout. So buffer layout. Okay, yep, close that off. All right, so we're calling bind here, and we're gonna bind the vertex that we're passing in. So let's get the elements. So var elements equals buffer layout.get buffer elements, and we're gonna set the offset currently to 0. And let's do a for loop here. So for int I equals 0, I it's less than elements dot count. And we'll do I plus plus, and then we'll do GL. Wait, nope, we want to set the current element, so we'll say var current element is equal to elements I. And then we have to enable the vertex attrib pointer, so we're just looping through. So the first one would be 1. So if we're in our texture, when we push the buffer layout, we're going to say push a float, and it's at 0.0, and then we're going to push the second float, which is at 0.1, or vec2 in this case. Well, it's a series of floats, but turned into vec2. So we'll do gl.enable vertex attrib array and I. And then we'll do gl.vertex attrib pointer I, and then it's the current element dot count, current element dot type, current element dot normalized, and then we'll do buffer layout dot get stride, and then the offset, and then we'll increase the offset by the current element dot count, and then let's make a method that's gonna get us the size. I know we're duplicating a little bit here with the buffer layout here, but I guess we could afterwards go back and update that. If you want to, go right ahead. Personally, I think this is fine, but let's create a new utilities class in core, because I think we kind of need just a utilities here eventually. So inside GameEngine.tk.core, add new item and call it utilities, and we'll make it a public static class utilities. We'll leave it in core, and let's make a method called public static int get size of vertex attrib pointer type, and we'll do vertex attrib pointer type. I'm gonna bring in the OpenGL namespace, and we'll say attrib type, and we'll do a switch on attrib type. And can I just, yeah. So we're gonna support byte, unsigned byte, and float. So let's just delete all of these. Well, let's create a lot. You might not want to have done that. You might want to just type them out on your end, but I don't think this will be too bad. So unsigned int and unsigned byte. Yeah, we'll just support that. All right, so when it's in unsigned byte, we'll return 1. And then if it's an unsigned int, we'll return 4. So it uses 4, it uses 1 byte, so it uses 4 bytes, and the same thing for float, because it also uses 4 bytes. And then we'll just return 0 if it doesn't find anything. And let's remove our using statements and go back into our vertex array. And then let's call that method. So it's the number of elements, so we need to tell it what's the offset. So it would be the count times utilities dot get size of a trib pointer type, and we'll do vertex attrib pointer, or no, current element dot type, and then that should take care of this. What's wrong with this? Buffer layout is less accessible method than vertex add buffer. Ah yes, buffer layout is not public. That error didn't make sense, but after looking at it, did. Now it does. Okay. So with all of that complete, I think we are pretty much ready to start replacing this in our main code. So let's go back to buffer abstraction here. And let's remove the vertex array object that will cause things to break. We'll comment this out, because this is where we're going to actually this is where we're going to define our buffer layout, because we're going to set, yeah, we'll go ahead and call it compile shaders. That's fine. No, that needs to change. We'll keep all that there. Although what we should be doing is checking if, I don't know, we should be doing something like this. We can't return 0, but we just return. That's a little bit cleaner. Okay, so we have our vertex buffer here. Let's declare our vertex array. So let's make a vertex array up here. I'll keep it by here. So private vertex array. We'll call it vertex array. And then that can be our first thing we generate, actually. So let's do that. So vertex array equals new. And then we need a buffer layout, so we can define this right here and then add that buffer to it. So what we can do is let's create a new buffer layout. First we'll comment this out so we know we're not using it. So let's say buffer layout equals new buffer layout, and let's push 3 floats. So we need to push 3 floats and we'll do layout dot add. It'll be of type float, and then we will add 3 of them, and by default we are going to normalize it. And then now we need to push 2 floats after that, so we can do layout dot add, we'll say float, and 2 of them. Okay. And then we don't need to call this here, but we're going to call the Vertex Array dot bind method. Okay. And we're calling bind, and we're still going to leave our draw there. You could argue that draw lives inside index buffer, but we're not going to do that. Alright, I think that is all. I mean, we didn't actually add the buffer, or the buffer to it. So we'll do vertex array dot add buffer, and we'll pass in our vertex buffer, and then our buffer layout. There we go. Buffer layout does not. Oh, layout. Yep. Okay. Let's try that. There we go. So that's good. I think that we'll stop the episode here. This is getting kind of long. I want to make sure we have time to process this information. One thing we're going to do in the next episode. The next episode is going to be fairly short. What I want to do is add a new shader that will allow us to define our rectangle, and then define the texture coordinates, and then define a color for it. And this will be great because we'll push 3 for the position, 2 for the texture coordinates, and then another 3 for the color. So that's what we're going to do in the next episode. I'll try to keep it short. I should be able to get that one out potentially even this weekend. I've been trying to stick to my promise of at least 1 episode per week. So if you like what you saw, be sure to like and subscribe, and we'll see you in the next episode. Thank you.